I should introduce myself. Sorry. So my name is Delia Scott. I'm an extension associate for Floriculture, Greenhouse, and Controlled Environment. And this is session 2 of what we are calling Greenhouse Educator Training. So this is something that we came up with primarily for greenhouse educators. So I'm assuming most of you all are affiliated with a greenhouse in some way, shape, or form. This is just to provide you all with some information that maybe you haven't seen before or you need more access to. We're going to try to kind of develop this around what your all's needs are. So again, if there's a topic you would like to see us cover, please do let me know. I think pretty much everyone has my email address. But if you don't have that, I can put that in the chat for later. But we have Dr. Jonathan Larson with us today, and he is an assistant professor and extension specialist for entomology here at UK. He is fantastic. He's funny. No pressure, Jonathan, on the funny part. Yeah, but I did send you all out with the description. Here's a really cool podcast called the Arthropod. I've actually listened to a couple of them, and they're really informative. So that's definitely something that you all should check out in your spare time if you have any. And one more thing I do want to add is that this is going to be the last one. We're going to break for summer because I'm assuming most of you are probably not going to want to do meetings over the summer. So we will resume this session in September. So keep a lookout for that. I do send it out to Matt Colliff, and I think that's who sends it out to you all. So keep an eye out on those on your email, like towards the end of August, we'll start this series back up again. But Jonathan, I'm going to turn this over to you. And again, thank you so much for being here today. And
thanks for having me.
There you go. Thank you.
Thank you for the introduction, Delia. I appreciate the chance to interact with folks tonight. Get back to the top of my slides here. So I am here tonight to talk to you just about some of the more common greenhouse pests. I'm going to guess that you know them, you hate them. You squashed your fair share of them while dealing with your greenhouses over time. But we're going to talk about the biology of some of these pests, and we're going to talk about some different management methods that we would call integrated pest management methods to deal with these. So I'm going to try and go through each of those pests and talk about some of those IPM tactics we can use against them. But I am going to focus up front on biological control. I've been getting, over the last couple of years, a lot more questions about biological control in terms of using it in high tunnels and greenhouses. So I thought I would share some information on that, particularly if you are all educating some younger generations. I think that they have a very keen interest in using the good bugs to kill the bad bugs. So I'll talk about that up front as well. When we talk about insects, of course, everybody assumes that we're talking about pests, and pests do pop up all over. And if you look in any agricultural setting, if you look in any home, there's a new statistic from NC State from a couple of years ago. Every home is inhabited by about 100 species of arthropods that we probably don't want to have there. So these bugs, they're everywhere. They live in all different kinds of places. But high tunnels and greenhouses and other interior scapes, I think, offer up some of our most unique and special challenges when it comes to dealing with insects and dealing with pests. Pests are pests for a reason. They tend to have very short life cycles, so they're able to reproduce really quickly. And then when you talk about an optimized indoor environment like a greenhouse or a high tunnel, that optimized environment provides an even quicker timeline for these things. So they tend to be more successful. They tend to be able to reproduce for a longer period in the growing season and to fit more generations of the insect into that session. The other situation that we have is that we're talking about very highly monoculture-like problem. So monocultures are the rule of the land if you go outside, but if you go into a greenhouse, especially big time production facilities, it's even more of a problem, I would say. When you line up all of a pest's favorite food in one spot and in nice rows, you can't really blame them for taking advantage of this buffet. It's just everything they could ever want, all in a nice tidy package, and they take very good advantage of that. And that's one reason that they end up becoming such a pest problem. All of the reasons that this happens kind of boil down to a lot of consistent heat in a greenhouse or a high tunnel. There tends to be a consistent amount of humidity, and then there's a certain amount of protection. If you look at some of the literature, particularly for high tunnels that's out there, we have really good evidence that things like tomato hornworms, they can be a problem in the field, but when you start growing them in a high tunnel, the greenhouse, it excludes their natural enemies. And so they're able to kind of run rampant in these interior scapes. It's a really fascinating situation where the pest takes advantage of a complete lack of things that want to eat it or lay its eggs in it. There's also the fact that insects, their entire life is really dictated by temperature, the amount of time it takes them to hatch from an egg, the number of days it takes them to stop being a caterpillar to turn into an adult moth. The sex ratios even of some of our pests are dictated by temperatures. Insects really don't like the cold. And if you've ever been in a greenhouse or high tunnel, you know that it tends to be a little warmer than the outside. And so that all really helps them to just have this wonderful environment that they're going to take complete advantage of, and they'll gobble up as many of our plants as they possibly can. The other thing that I would point out in these interior scapes is that insects that live in there, they're more successful. They're able to recover very quickly from problems that they encounter, such as an insecticide. And they can sometimes even sort of out-reproduce these problems that they encounter. And this quick recovery and reproduction time that we see with pests is two of the things that are essential to insecticide resistance. So when insects are sprayed over and over and over again with the same products, which we do a lot in pest control, if you're dealing with more and more generations of them, you may end up doing that in a greenhouse as well. You're increasing the likelihood of this random mutation occurring. You're putting pressure on the population to change. And eventually there will be a female or a male that has resistant genes. They're able to pass those on to their progeny. And eventually we keep killing their competition. And the only things left are these resistant, the red bugs in my example here, these super insects that can no longer be killed by products that have classically been successful for us, things like carbaryl, things like bifenthrin or some of the other pyrethroids. We do see resistance pop up with these. And it happens a lot, it seems like, in greenhouses because of the pest pressure and then the resulting insecticide pressure that we use on those pests. So for all those reasons, we have to talk about IPM when we're talking about greenhouses. And IPM can be challenging. It can sound like a lot of work when people hear about it for the first time. But I really think that for greenhouses in particular, it's the most successful way of going about biocontrol or about going about pest control. And it's also something that works better for people that are in greenhouses when compared to the field. So this integrated pest management program, it's a philosophy of pest management that focuses on using sort of all the available tools at our disposal. A lot of people focus solely on using chemistries in order to control pests. And really they should be looking at this whole toolbox that we have. And instead of always going for the wrench or the screwdriver, realize that there's lots of options in that tool belt, in that toolbox. So in my example here, we've got a pyramid that sort of shows you what should be the typical IPM approach, using things like prevention first and foremost as our foundation. Outside, this can be choosing the right plant for the right place. Indoors, this can be simple things such as quarantining or checking plants before you put them in. We've also got cultural practices, things like sanitation. Those are the next step. Then we have physical and mechanical control. That's things like squishing pests in some cases or excluding them using tents to try and prevent them from getting on certain plants. Then we have biological control, and we end with chemical control, hopefully being the top of the pyramid. If you grew up with the food pyramid, you may recognize that one as the part with Reese cups and Mountain Dew and everything. The same is true for our chemical control when we're talking about pest management. It should be sort of the last line of defense, and it should be used the least often in an IPM program. When I talk about IPM, some folks, they think that I'm trying to tell them to be organic. And this is not an inherently organic process. It can pair well with organic production choices. Using organic products can often fit into an IPM model really well. But IPM and organic are distinct. Organic just means no synthetic products. You can't use anything that we have made or optimized in a lab. You have to focus on using things like copper for a fungicide, or you may use nicotine for an insecticide. But you couldn't use a neonicotinoid, which is a synthetic version of nicotine that we've built in a lab and sell as an insecticide. So organic, that's one end of the spectrum. On the other end of the spectrum, sort of opposed to IPM, we have heavy insecticide use. I call it the Clint Eastwood approach. You just spray them all and let God sort it out. Just say, die, die, die. Let's kill all these bugs. And that's definitely not IPM. IPM really is wedged kind of in the middle of these philosophies. Used to its fullest extent, IPM includes things like insecticides and other pesticides, but at a lower rate. It'll help you to suppress pests. It'll help you to reduce costs, and it helps you to stop putting out so much pesticidal residue in these environments that you work in. So it is in the middle here. It includes insecticides, it includes organic products, but it's a more judicious use of those products. With this approach, the first thing that we have to do is make sure that we're monitoring for pests, though. This whole thing falls apart if we're not paying attention and finding these pests before they become a problem. A lot of pest control has become very reactionary. We don't do anything until the pest is already kind of well out of hand, and we have to go for the nuclear option first. If you're doing thorough monitoring for pests, you can stop them before they reach that level, and we can use some of these other IPM techniques that we're going to talk about today. So in order for those to be successful, you have to find the pest before they explode in population. The reason this works is because you catch populations when they're at their most vulnerable. This has sort of a two-pronged approach. One, you're finding their populations when the population itself is lower. There's fewer organisms to manage, and therefore it is easier to get rid of them. Rather than trying to deal with 100,000 bugs, you're dealing with 100 bugs. It's a lot simpler when you have to do that. They're also weaker if you catch them at certain points in their life. Insects, as they develop, they go through one of two kinds of metamorphosis. You can see this here in these two diagrams on the right. We have an egg and this one in the middle. The egg hatches into a caterpillar, which will then pupate and then turn into an adult. We call this complete metamorphosis. Complete metamorphosis is so called because they completely change from their immature larval stage into the adult stage. And there's this sort of transitional phase in the middle called the pupa. In this situation, you have two life stages, the pupa and the eggs, which are almost impenetrable. You can't control them. And adults are often very difficult to control as well. So we have to target the larvae. You have to find them when they're in that stage, and hopefully even smaller. So you find them in the first instar or second instar, which is sort of like first or second grade for the caterpillar, and you kill them then. They're weaker, they don't control they don't have enzymes that break down insecticides very well. They're just a lot easier to destroy. The same can be true with pests that have incomplete metamorphosis. My example here is an aphid. They're an egg, the egg hatches and out comes a nymph. The nymphal stage looks very similar to the adult. It just gradually gets bigger in size until it develops wings, and then they've reached adulthood. And again, you have to control those nymphs when they're very small and at their weakest so that we can get rid of them. This is all very helpful when we're trying to use some of these IPM methods, and it's what a lot of them are based around. If you miss that early detection window, you're going to end up with more damage. You'll end up with overlapping life stages. You'll have eggs and pupa and larvae and nymphs and everything all at once happening, and it becomes very difficult to parse through. It becomes very difficult to manage, and you end up with a lot of damage. This is when they enter what we would call the exponential growth phase. You see on this chart here on the left. And then at that point, your only option to save what you're trying to grow is going to be insecticidal intervention. You'll have incurred a lot of loss. It's not a great situation to find yourself in. And unfortunately, we've all been there. So in order to avoid some of that, we need to monitor the plants. Monitoring can be done directly on the plant, getting up close and personal, selecting random individual plants from susceptible areas, saying like, okay, I'm going to monitor this plant that's closest to this door that we walk into, and I'm going to monitor that plant that's in the door, that's by the door on the other end of the greenhouse where everybody leaves. Or I'm going to check this row on each side that's closest to the wall, and that's where I'm going to monitor. But you need to pick a selected area and then stick with it until those plants are harvested. You can also monitor directly on high-risk populations, plants that you know are going to end up with plant pests, or on high-dollar crops. If you've got poinsettias, you know that you need to focus some monitoring efforts on those in order to maximize their visual appeal so that you can maximize the dollar you're going to get out of them. All of this helps when making these decisions. What's my most important plant? What's my most at-risk plant? And then which ones am I going to prioritize? When you get up close and personal with the plant, I find it's easiest to do this with a magnifying glass or a hand lens. If you wear bifocals or if you have reading glasses, make sure you bring those with you as well. Anything that you can use to sort of magnify what you find on the bottoms of leaves. This is a very important thing to remember. Pests, they're not very polite. They're not going to be out on the top of the leaf waving at you like, hey, I've moved in, I hope it's fine. I'm just going to steal some of this plant sap. I'll be out of your hair real soon. No, they're tricky. They live on the bottom sides of leaves. They live down in buds. They live down in the flowers, anywhere where they can't be perceived as easily. So you have to get in there and peel things apart. You have to look at the bottom sides of leaves, and you have to look for the things that the insects leave behind or the insects themselves. So when we talk about this in entomology, we talk about signs and we talk about symptoms. Signs are the actual pests themselves. This is a sign that you have a problem because you saw what you thought was a thrips, or you saw what you thought was a mite. So then you go and take a closer look. Usually what we perceive are the symptoms, the effects that the pests have left behind. Symptoms come in a variety of forms. When I talk about each of these pests here in a moment, I'll talk about some of their classic symptoms. But these plants on the left here, you'll see all these gnarled and curled and cupped leaves. That's a very good indicator that something is feeding on those plants, probably an aphid. These sap-feeding pests often cause this wilting symptom. You may also notice something like stippling, which we see on the right here. These leaves that look kind of pixelated, like bits of the green have been stolen from them. This is a good indicator usually of something like a mite problem. These symptoms are very indicative. They're usually what we notice first, and I'll try to give you some tips and tricks for finding those with each of the pests we discussed tonight. Another direct monitoring method is to get up to the plant and use sort of an adapted beat sheet method when collecting specimens. In entomology, a beat sheet is this big bed sheet that we have kind of that's got almost like what you would put behind a kite, this wooden cross in there that supports it, and then you turn it over to the sheet side, and then you hit plants over the top of it, or you get your friend that's also a weird entomologist to shake the tree really hard, and then bugs fall down on the sheet and you're able to collect them and take them home and pin them. For you all, with plants that are much smaller and pests that are much smaller, all you need is a white piece of paper, and you get up close to the plant and you tap it over the top of the paper. If there's any pests in there, they'll start moving around on the paper, and then you can either curl the paper and dump them into a cup or a container so you can get them identified. You can squish them. Make sure you de-infest the paper before you go to the next plant. But it's just a way of getting those specimens directly so you can make some identification and diagnoses. In addition to this direct monitoring, which requires your presence for you to physically be there, touching the plant and looking at it, you'll want to have passive monitoring as well. Passive monitoring is done even when you're not there. Passive monitoring in a greenhouse typically involves sticky cards like we see here. The sticky cards are there 24/7, no matter what, they're working for you, just like a State Farm agent. I think that's their slogan. If you look at passive monitoring, you'll find that sticky cards, they come in two colors. For greenhouses, you can buy yellow or blue, and they're sometimes sold as sort of front and backs where one side is yellow, one side is blue, or they're stuck together. You can also buy them separately. If you have to buy just one type of sticky card, I would encourage you to think about yellow more than blue. Blue is usually advertised as being very specific for thrips. It does catch thrips, it catch a few other things. I've got a whole stack of them sitting over here waiting for me to do some ID work on, but they don't catch everything like yellow does. Yellow as a color attracts aphids, it gets white flies. I've seen spider mites on them, thrips, fungus gnats end up more on the yellow ones, it seems like. It just seems like they catch a lot more. So if you need to budget for these, yellow would be the one to go with rather than the blue. If you can afford both, I would encourage you to do both. You do have to put multiple traps out, usually 1 to 2 traps for every 1,000 square feet of space. I also like to encourage people to put one near the door and near the edges. So that gets you up to maybe 3 or 4 that are in the tunnel or in the greenhouse, depending on how big it is. And with these sticky cards, you have to put them on poles or on like a metal clip that comes with them so that you can adjust their height. The sticky card should track the top of the plant. As the plant grows, the sticky card should grow with it. and get taller up on this pole. What we do a lot in my lab is we take 2 clothespins and we glue them so that you can clip on one side to the card and clip the other side to a bamboo pole, and then you just slide them up and down. They do sell these metal wire things that do something similar, sometimes through companies like Arbico Organics. But ultimately, what matters is you just keep that card tracking the top of the plant. That way it's monitoring the correct things for you. Other things to monitor are new plants, recently purchased stock that you're moving in. If you're buying starters from somewhere else, you're also buying any problems they may have been brewing there. A couple of years ago, I dealt with a grower who he had a heater fail on one of his greenhouses. He lost all of the tomatoes that he had started. So he went to another producer who had a surplus and bought their tomatoes. And he also bought about 1 billion aphids, it seemed like, and they just took over all of his greenhouses. So you do want to check those things when you're buying them, when you're bringing them in. You may even want to consider quarantining them, put them in a separate area for about a week or 10 days. We're all familiar with quarantines after the last couple of years, and thoroughly inspect those plants as you bring them in. Put sticky cards near them, do more frequent observations of them. All of this will help to protect your other stock and your other tunnels from becoming infested. You can also monitor using trap crops. Trap crops can be tricky because you're talking about putting a plant out that's attractive to pests and also something that you have to buy, and then you're just basically going to let it get eaten alive. So some qualities of these would be that they're cheap and they're easy to see because they need to be a focal point. So a plant that sticks out from the plants that you want to protect, the one in the center here, this marigold growing amongst all this other greenery, is very obvious. It's easy to go straight to that plant and expect it. In my experience, marigold is a great trap crop. They get a lot of pests on them, and those crops will be infested first as a preferential site over the other ones that you have. And then that means you can dispose of it. You can treat it directly and hopefully kill a lot of the population before they spread off of that trap crop into the other ones. You've got options with these. You can also just simply throw them away and get a new one out to keep monitoring because it's done its job. It's trapped some of those pests for you. I would also encourage you to keep records of this. I know that paperwork is nobody's favorite thing, but making a map of where you see the pests at in the tunnel or in the greenhouse so that you have sort of a historical perspective over time, making sure that you write down where you see the problems, what they are, how often you're seeing it in a season. You can make a chart then that tells you, okay, last year and the year before, by May 15th, I ended up with aphids on all of these pepper plants. It tells you that you need to go out there and start doing that inspection. It just gives you evidence. It gives you data that you can use to know what to do next. So if you want, you can find these online. They're provided by a lot of people. Just look out for Greenhouse Weekly Monitoring Form, or you can make your own that works best for you. Another option following monitoring is to make sure that you use sanitation to prevent pest buildup. So if you've got plant debris that's accumulated, I already talked about removing the trap plants from an area, isolating infested plants. If everything's in pots or little containers, you can move them away from other plants that aren't infested and treat them or dispose of them. One thing this year that I've been really interested in watching was that I've dealt with several situations that you guys have been able to see this the whole time, right? It said just now that you could see it. I just want to make sure I haven't been talking to myself.
Jonathan, it's good on my end.
Okay, cool.
Able to see everything. Yeah.
It just popped up and said like, oh, participants can now see your application. I was like, oh, I hope they've been able to see it this whole time. Thank you. The thing that I've seen this spring a couple of times that's been kind of interesting is I've been called to 2 or 3 greenhouses where they were complaining about early aphid problems. They really didn't understand where they had come from. And it was all about weeds. They had weeds that were encroaching from the exterior perimeter of the greenhouse. They were poking in underneath, or they had paths in the center of the greenhouse, which were infested with weeds on each side. The weeds were never treated. They weren't in an area that was a problem. They weren't taking nutrients from the plants that were getting grown in there. You shouldn't be using herbicides generally anyway inside of these places. So they hadn't done anything to them, but they also never treated them with insecticides. And I got them down on their hands and knees and were crawling through this greenhouse, and every weed that we would find was loaded with aphids. That's what you're seeing in this far right image here. they become bridges from the outside. So aphids that have overwintered outside can crawl in, and they become banks inside for pests. You kill all the pests on the plants you want to protect. Well, there's still a bunch of aphids and things hiding out in these weeds you didn't treat, and now they just get to reinfest from there. So you do need to sanitize those, weed them out, treat them with an insecticide if you want. But remember that weeds are plants too, and those pests are going to take advantage of them if they don't have any other option. The same factors that we've been talking about that help the pests in these controlled environments also will aid beneficial organisms that we release in there. This opens the door for alternative pest strategies like biocontrol. Biocontrol in its best forms have been focused on the greenhouses and the high tunnels that are out there. If you think about this, I think it makes a lot of sense. In a field setting, biocontrol agents are very likely to escape. You are a ladybug in this scenario. Just imagine it that you're a 7-spotted lady beetle. You've been put into a box and shipped through the US Postal Service. And then they open that box when you get shipped from Phoenix, Arizona to, let's say, I don't know, London, Kentucky. And they open that box. The first thing you're going to do is be like, see ya, sucker. Thanks for the shipping. And you're going to fly away because you've been trapped in a box. You probably haven't eaten. You have no reason to stick around in that spot. So they often flee. They may feed on lots of alternative prey. They could get killed by the weather when you release them. But in the controlled setting of a greenhouse or high tunnel, we see that they're trapped there. They're stuck inside usually. They don't escape as well. There's usually only pests for them to feed on, maybe some pollen if they need it, but there's a lot of food for them to feed on. And they're just going to stick around. They're going to stay in there and live and devour some of those pests that we have. There's a lot of industries that don't have these options, but this is there's a bunch of proven protocols for greenhouses. You can work with companies like Rincon, Vitova, Coper, and Arbico. All of these provide biocontrol organisms. They provide them typically at pretty economic prices. The thing that gets you is going to be the shipping because it has to be overnight usually, and that doubles the cost of what you're doing. If the bugs you're buying are $80, the shipping is probably going to be $80. You're probably going to spend about $160. If you want to use biocontrol, there are some considerations to keep in mind. It does require more effort and more management. You are going to be putting these bugs out, monitoring for these good insects, making sure they're actually eating what you want and intervening if they're not. You're never going to fully eliminate a pest species with biological control. If you do, you bought too many biocontrol agents probably, and they're all going to die out. If you get it at the right number though, they'll eat the pests, but there'll always still be some pests around, and it sustains the biocontrol agents population. And they always keep those pests suppressed to a below an economic injury level. You do have to know what you want to kill. If you have aphids, but you've identified them as thrips, and you buy something that eats the wrong thing, it may not work against the pest that you actually have. And I already mentioned the high upfront cost. The advantages, you will reduce your insecticide use. That lack of residues is good in a teaching setting and safe for people that are going to come in and buy things when you get your Mother's Day sales going and things like that. There is the potential for self-sustaining populations, as I alluded to before. If you do it right, you'll usually have season-long control, and ultimately you pay that upfront cost, but you don't make repeated applications of insecticide over the season. And so it does end up saving you money in the long run, which could result in higher profits. If you beat one of your enemies with biocontrol, you can't say, yes, I've won, and kind of rest on your laurels. You need to keep monitoring and be prepared to deal with the next set of pests. So if you had aphids and you got rid of those, remember that the thrips can be not very far behind, and what you bought for biocontrol against the aphids may not necessarily work against the thrips. So you're going to need to do something for them. You're going to be paying attention for the duration of the season. And if you do biocontrol, I just have to reiterate, you have to make peace with there being some pests present. They're always going to be there. They're never going to eat all of their food. There's still going to be a few pests around. You just have to make a mantra of it that a few aphids is okay. You know, it's not the end of the world. Rarely will that full control be obtained. If you can't have any damage whatsoever, you have to have perfectly pristine plants, then biocontrol probably isn't for you. You'll want to think about some of these other management strategies we'll talk about here today. Some of the pests that I wanted to mention today, and I think I got time to go through several of these. There are lots of different pests that can pop up. Mites are some of the most difficult ones to deal with, I think, in controlled settings, because they just do really well in these situations. There are multiple species of mite. I'll focus on 2-spotted spider mite today, but you could also see Lewis mite, broad mite, tomato russet mite, cyclamen mite if you're growing violets and things like that. Mites are interesting because they're closely related to ticks and to spiders. They're arachnids. They have 8 legs as adults, and they have little fangs, just like we see on a spider, and a body plan that looks very similar to a tick. And they're kind of like plant ticks. They get on them and they start sucking fluids out from that plant. The 2-spotted spider mite and its friends in the spider mite complex, this is a group that causes the most damage. They attack over 300 species of plants. One generation can complete development in 8 days, which is astonishing if you think about it. They go from newborn to senior citizen within 8 days, and then the next generation is born. Females lay over 100 eggs apiece. They are found most often on the undersides of leaves or around buds. They prefer that tender growth. It's easier for them to feed on. The 2-spotted spider mite, I bet you can't guess how it got its name. If you look at it, how many spots do you see? Bada bing, bada boom. Entomologists are really boring people. We tend to name things very on the nose. So the 2-spotted spider mite has those 2 greenish black spots on its back. In terms of symptoms to look for with these pests, you'd be looking for the stippling. As they feed, they suck out those juices from these small spots because they're so tiny. It leads to this pixelation on the leaf. It can be on the top or the bottom. Another symptom is that there may be webbing. Spider mites get their name because they produce web similar to a spider. They don't do it in the same fashion. Spider web comes from their rear end. Spider mite silk comes from their mouth. They spin it and kind of traverse across it. You may also see distorted leaves that get kind of twisted and leaf drop. You can identify them through those symptoms. You can use the beat sheet method that I mentioned before to find the mites, and beans in this situation can be a good indicator or trap plant. If you grow beans next to the things that you want to actually protect, they'll go to the beans first and foremost, and you can control them on that plant or dispose of them and prioritize your insecticides for later on. The IPM methods for spider mites includes a lot of sanitation and careful observation of trap plants and new plants. You can buy biological control when you start to see spider mite problems, and it will suppress their population to a lower damaging level. This is a predatory mite called Phytocilus persimilis. It's the red mite there that stabbed the spider mite in the rear end and is sucking all of the juices out of it. Very sci-fi, very alien, but they do go through and they kind of murderize these spider mite populations, and they help you to really reduce them. Not necessarily rapidly, but they do help you to maintain that suppression long-term. Chemical control of mites, on the other hand, can be very difficult. If the mite problem's gotten out of hand, you have to be very cognizant of the fact that we're talking about mites, which are not insects. Insecticides are built and tailored for insects. If you use an insecticide against a mite, it might work or it might not. So you do need to think about miticides over the insecticides. Miticides that work in the greenhouse setting can include abamectin, sometimes known as Aphid, etoxaxyl, tetrasan, chlorphenapyr, pylon, and spiromesiphin, which is called judo sometimes. These trade names are not me endorsing those products. It's just examples of these different chemical names. But those all work quite well against mites. Some of them are translaminar, so they're absorbed by the plant and held in it, so that if the mites come back later, those residues will still be there to control them. I will say, I might talk about a imidacloprid or a different neonicotinoid here today. If you use those products to control other pests, you can get mite flares, unfortunately. Those insecticides, for some reason, they seem to offer up the opportunity for mites to just explode. So you have to be prepared for that. Another pest that we can see is the fungus gnat, very common problem in containers and in protected areas. I get a lot of fungus gnat questions starting in October when people are bringing their plants in from outside and they start having these gnats appear in their home. And I get a lot of questions about them at the early start of the growing season from professionals. Generally speaking, the adults of these kind of resemble skinny mosquitoes. They have long legs and dark bodies. They're also known as the dark-winged fungus gnat because their wings are slightly darker than other fungus gnats, but they have just a very basic body plan. The maggot is the more interesting looking stage, I think. It is a white, sort of thin and slimy looking organism with a distinctly black head capsule. They love to feed in the root zone area of young plants. They do occasionally cause stunting. They do want to feed on fungi instead of other things, but if the fungi aren't there, they'll feed on these seedlings and destroy them. They do prefer a higher moisture content. They can be monitored for by slicing a potato up and then putting those potato slices in select plants, like maybe every third or fourth plant, and then going and checking that potato slice every couple of days and replenishing it when it dries out. They like to go up into that. It's good food for them. And so they'll go and attack it. And that can be a little trap crop kind of thing for you. The other thing I'll point out with these maggots is that sometimes they emerge in mass and they glom together into this big slimy snake shape. And then they crawl around like that. I've gotten some panic phone calls in regards to that. They do mimic a snake so that other things won't eat them, hopefully. But you may see something weird like that if you're very unlucky. Fungus gnat control, it focuses on an IPM tactic through sanitation or just physical control. If you can reduce the moisture by cutting back on watering or improving filtration so that moisture doesn't get retained as much. If you sanitize around the area and get rid of damp areas in the greenhouse where maybe they're hanging out, if you can put a fan on those and dry them out, that would be helpful. Adults can be killed with contact insecticides. So permethrin and a few others can be put on leaf surfaces. So when the mom lands on the plant to take a rest, it kills her. That is a very tough row to hoe, though. That can take a lot of insecticide and time. So it's better to go after the larva if you can. Again, as I mentioned, you want to go at them when they're the weakest, and that's the larval stage here. So solutions like Natrol, which is an organic BT product, it is sold commercially. It is widely available. It gets into them and kills them. You can also use biocontrol by using predatory nematodes. Nematodes are these little squirmy worm-like organisms that you see next to the fungus gnat larva in the right-hand image. They will infest it, eat it alive, and then pop out of its corpse and go do it to another one. So there are options with these. It isn't a hopeless situation. Then we have to talk about aphids. Aphids are some of the pests that I hear the most about, particularly in greenhouses. There are many species, I won't list them all, but they're all phloem feeders. And that means that they use a needle-like mouth part that we see on the left here to suck juices from the plant. If you're worried you're dealing with an aphid, the way to confirm that it is an aphid is to look at the tail end. If it looks like it has these hot rod tailpipes kind of sticking off the back here, those are called cornicles, and only aphids have them. These are sort of a defensive system for the aphid. They release pheromones from there when agitated that are called alarm pheromones, and it makes all the aphids go bah! And kind of let go of the plant and fall off, hopefully to escape whatever it is that's trying to kill them. Aphids are not always green, though that is their most famous coloration, is this green body plan. Some aphids are green all over, some are green with black feet and black antenna. Some aphids are red, some are yellow with black cornicles and black legs. Those are called oleander aphids. If you grow milkweed, you will get oleander aphids. Some of them are big and gray or black in color. So they do come in lots of shapes, sizes, and colors, but they always have those cornicles. They're very famous for reproducing through asexual reproduction. Most of the time when you find aphids, the population is entirely female. There are times in the year where they will mate and the female will lay eggs with males that fly in, but generally speaking, once they get going, the aphids are all female. She gives birth to live young, which is what you're seeing here. And then those live young are able to develop quickly, and then she'll give birth to a clone of herself. So they're all related to each other. Since they feed on the plant's blood, basically, they are capable of acquiring and transmitting plant viruses as they feed. An aphid's diet is made up completely of sugar water. Imagine if you drank nothing but, I don't know, Dr. Pepper and Mountain Dew all day. That's their diet. And if you did that, you would poop out sugar water as well, which is what the aphids do. We call it honeydew. And honeydew accumulates on leaves. It leaves a very sticky mess. It can happen on flowers. It can happen on people and cars and homes outside as well. If you are looking and you see sticky leaves on a plant, I always encourage people to look up. If you've got anything growing above those plants, that's probably where the aphids are. This stuff drips down. If there's no plant above, check the leaves above the sticky leaves, because that's where the aphids are. It has to drip down from somewhere. So look up, look in the higher spots. You can monitor for aphids by checking for that honeydew. You can look for deformed leaves. When they feed, they cause the leaves to cup and curl, which gives them a nice hiding spot. They also shed a lot of exoskeletons. So you'll see what looks like white powder accumulating at the tips of plants most often. Yellow sticky cards capture a lot of aphids. On the right here, you can see 2 aphids and then a thrips kind of caught between them. If you bring in new plants or those weeds are growing in, those are often bridges or things that bring the aphids in. So I would encourage you to look at those very closely in terms of monitoring. Aphids are also very popular prey items for biocontrol organisms. Lady beetles love aphids, lacewings love aphids, and wasps love to lay their eggs in them. A lady beetle is the most famous example of an aphid biocontrol agent. Lady beetles, from birth to death, they eat about 5,000 aphids over the course of their life. You can see one devouring one on the left here. And then on the right, we have a lacewing larva. Lacewings as adults are green and thin usually. They have very nerve-filled wings. Their wings look like they're full of little veins and nerves. As immatures, though, they're called aphid lions. They're these sickle-mouthed organism that you see on the right here. They go through and they gobble up aphids, and they love to do it. Aphid lions are easy to acquire when you treat with them, when you put them out for aphids. They also tend to stay around because they don't have wings, so they can't fly anywhere. So they're going to stick around, eat a bunch of aphids, and then mature, and then their moms will hopefully lay eggs in your greenhouse to do it again when the next generation of aphids shows up. Oh, here's a little video of an aphid being devoured by a lady beetle. It always astonishes me that the aphid does literally nothing to fight back against being consumed alive by this huge tank-like organism. Just watch him slurp it up like a piece of Alfredo. There goes the aphid. I love watching that. Braconid wasps also like to use aphids as incubators. These are small wasps. They don't sting people. They don't have a nest. They're solitary wasps. They fly around. They poke their stinger into the aphid, which you can see on the left here. They inject their egg. Then their baby wasp is inside eating the aphid alive. It causes the aphid to mummify, which you see on the right here. If you see these puffed up aphids and they don't have a circle cut out of the back, that means there's still a wasp in there, so don't squish it. Once you see this porthole that's kind of cut out of the rear end, that means the wasp has emerged as an adult and you can wipe those off. But this is free biocontrol that's suppressing aphid populations all around you. And I find these in every greenhouse I go in the state of Kentucky, even when people haven't bought them. It just happens naturally with the way that these pests pop up. With that, I will talk about insecticides that can help with aphids. There's lots of them. There are insecticidal soaps and neem oils that help, which are both organic. You have to be very careful. Plants don't like those products when it gets over 90 degrees, which can be pretty early in the season in a greenhouse. So you got to be very conscientious of that. You may want to switch to using things like pyrethroids. Those are common insecticides. Things like bifenthrin are very good against aphids, does wipe them out, although they can come back once those residues are gone. So you need to pay close attention and see if you get any recolonization. That means that sometimes it's better for people to use a systemic soil application of imidacloprid or dinotefuran. You treat the soil that you're growing the plant in at the label specified rate. The plant absorbs it. The aphids take one drink of the plant and then they're killed. Those aren't available for everything. If you're very conscientious about pollinators, you may know about neonicotinoids and know that there's some people who are very against them. So if you're trying to sell to pollinator groups and things like that, if that's part of what you do for your clubs, you may want to hold off on the neonics, but they do help quite a bit with aphids. I think that means I have taken myself to the time. Delia, is that right? I'm at 5, right?
Yeah, we go till 5, but you can finish up, Jonathan.
Oh, I got a couple of more pests if people want to hear about them. I'll just do thrips because I know that they pop up pretty often. Thrips are very small. They're about 1/25 of an inch. They develop through a whole generation, again, really rapidly in a greenhouse. So in about a week to 2 weeks, thrips are part of a group that we call the fringe-winged insects. because if we look at their wings, they have these hairs that stick off of them. It looks like a Davy Crockett kind of jacket. That's how they get their name as a group. Thrips, if you dig around, it's both the singular and the plural for some reason. So you have one thrips, or you can have three thrips, but it's always thrips. There are tobacco thrips, western flower thrips, and eastern flower thrips. We generally see the western flower thrips in samples that I receive here on campus. Populations are mostly females. They insert 150 to 300 eggs into leaves. The eggs will hatch. The resulting immature thrips will come out and feed. They have asymmetrical mouth parts. They actually slash the plant with half their mouth, and then the other half of their mouth is a straw. So they're kind of cutting and slurping all at the same time. And because of that slicing and slurping, they lead to these deformations that we see here. We see silvery flecking scars. They feed on the liquid contents of the plant, so they can transmit viruses as well. They also have very distinct fecal material. They have black feces when it comes out of them. It looks like somebody has dipped a toothbrush in motor oil and then kind of sprinkled it lightly on the plant's leaf surface. So silver flecking, black drops, that is a good indication of thrips. They also have favorite colors. They like blue, yellow, and white. If those are your school colors, you may end up with more thrips problems because they'll fly on you outside and then you bring them in on your clothes. You can also bring them in on infested plants, but they'll also just fly in. These thrips, once they get in, they reproduce really quickly. You can monitor for them with those blue sticky cards. You can monitor for them using just visual identification. Biocontrol can be through the use of predatory mites or a predatory thrips itself. On the left here, you have a thrips eating a bad thrips. So a good thrips is devouring the pest thrips. You can also use a fungus, which we see on the right here. That's Bavaria bosleana. You spray this fungus out, it infests the pest insects and kills them, and it doesn't do anything to the plant or to people. So it's a pretty interesting biocontrol agent. There's the mites that we can use against thrips. There's 3 different species that I see for sale very commonly. If you're going to use mites, you need to have pollen available for them. You can apply pollen so that they can feed on it, or you can skip the mites and go with the predatory thrips, which only feed on the thrips. Then with insecticides, we have spinosad. That's the best option. It is organic. It works really well against thrips, and it is not going to cause a lot of problems for the plant. Neem and insecticidal soaps, again, with the caveat that plants don't like them when they're warm. So you may get some phytotoxicity, but they do kill thrips quite well. And then abamectin, bifenthrin, and acephate are traditional insecticide options for the thrips. And I appreciate your time tonight and let me do an extra bug. If you have any questions, I can show you my contact info. I am jonathan.larson@uky.edu. I'm also on Twitter @bugmanjohn. I do accept samples through Twitter. If you got a photo, you can email it to me or tweet it at me or direct message me, and I would be glad to try and help you figure out what you're dealing with. But good luck this growing season. I hope you don't deal with a lot of these pests, but I know that they'll pop up. So if there are any questions, I'll take them now.
All right. Any questions? Do feel free to unmute yourself, or you can pop them in the chat box. But Jonathan, that was great. Thank you so much for that.
Thanks for having me.
Appreciate it. All right. Last call for questions.
I'll take a big drink of water.
Okay. And also, just as a reminder, we're going to take a break for this session for the summer, and we will start back up in September. You all have my email address. You have Jonathan's email address. If you have any questions for any of us, please do feel free to reach out. We are here to help you all. But thank you all for attending today. And yeah, thank you again, Jonathan. We appreciate it.
Anytime.
All right.